Can we get a yes in the chat?
Well, I suppose I may as well just get into things then. All right, so hello everybody and welcome to the SRHacks Engineering Design Workshop. My name is Ben Drakich and I am a third-year chemical engineering student at the University of Toronto. And I'm going to be talking about engineering design today, what it is, how we use it, that kind of thing. Currently, I'm also occupying a position at Hatch Engineering, so I've had experience both in the academic setting and the professional setting for using engineering design. So just getting into things really quick. Here's a quick overview of what we're going to be covering today. We've got like a quick introduction, and then we're going to be talking about what the design process is and defining a few terms and providing you guys with an understanding of how to apply those terms to a variety of different examples. And at the end, giving an opportunity for you guys to dive in and apply what you learned during this presentation to a example right from the top. So this is going to be a bit more of a theory session, a little bit more, I saw what was going on in the previous presentation. It looked very cool. That's very practical coding skills. This is going to be more of like a theory for how to approach discussing your design and to provide a framework for categorizing different aspects of a design when you will be submitting it into the video submission at the end of SRHacks. So you're going to be using what you learn here in those submissions. I would highly recommend, as a result, taking notes on anything we do cover. If you have questions or clarifications or anything like that, please type it in the chat. The moderators, Mimi, will try and get to as many questions as she can, but any leftover questions I will cover in a Q&A session at the end of the presentation. Okay, so I guess without further ado, let's get into engineering design. So big question I had when I came into engineering in university was, what is a design process? I don't even know what that means. And I think that's a very valid question. It's not a very clear term. It's not used in other places. Is this the engineering design process? Maybe this? It could be a lot of things. At its most simple, the engineering design process is just a structure or a framework used to simplify the process of creating a design, because designing is hard. So I'm going to get the chat a little bit involved here and say, here is a design example, just to give an understanding of why we use a design process, because it's a little bit strange. It's a little bit unusual. Could I have people type in the chat? If you were designing a car, what factors would you consider? So what things, if someone says, look, I need a car, what are the things you're going to have to think about if you're making the car? Not like at a deep level, not about like engines or catalytic converters or like how any of the chemistry or mechanics works. Just what key parts of a car are you going to need? Okay, I'm seeing a lot of good answers. Okay, so I'm noticing a lot of really good contributions. Thank you guys so much for typing in chat. We have, let me just read out a few examples. We've got things like how it can stop. So like a braking mechanism, really important. You need to be able to stop your car. Padding, like making it comfortable for the user, also super important. Wheels for motion, the materials it's made out of course, that could tie into like cost or size or weight or any number of factors. I hope this goes to show just how complicated a design can be. And all of you are giving different answers. Sure, there's some overlap, but everybody has like a different idea of things to consider because this is a complex problem. This is where the engineering design process comes in handy. It's a way that we can take everybody's different ideas and give a uniform set of rules, a uniform language for everybody to follow when they're designing something. So it's like what it's a structure, essentially. That's what we're going for. So for the car example, this is a few examples that I put down, like your size, your cost, your fuel type, speed, any standards or codes, things like that. There's a ton more examples. You guys named some really good ones that I didn't even think to include on here. But the goal of the design process is to simplify this part of of creating a design. It's if everybody speaks the same language, it's really easy to communicate. And the engineering design process groups ideas like the ones you guys mentioned into these buckets. You'll see here the problem statement, external considerations, and project requirements. Within those are subterms that we'll define in a second. But basically, the engineering design process is something that was defined by people far smarter than I a long time ago, where they noticed, hey, wait a minute, we keep making things, we keep doing it from scratch, right? But these ideas at a base level keep coming up over and over again. Yeah, maybe I'm making a car or a plane, or I'm designing a building or whatever, but these ideas keep happening. We keep stumbling into them. Is there a way that we can create a procedure that has defined terms that let everybody be on the same page? It's kind of similar to science or math, where you come up with these weird and unusual words for things so that everybody who understands what they mean knows exactly what they mean. When you're talking in the math realm or the science realm, why is everything in Latin in biology? It's because everybody understands that language in its use in biology. It's a similar thing with the engineering design process. So each of these terms, we're going to go bucket by bucket through the problem statement all the way to the project requirements and talk about each term in there, because they all have specific definitions, and we're going to cover sort of how to approach categorizing the things in your designs into those buckets. So starting off the problem statement, this is the definition of everything you're going to do. It's like when you're given a question in math class, your goal is to answer the question. When you're designing something, your goal is to create the question and then answer it. So the problem statement is an opportunity to create the question, to say, okay, someone has come to me and they have a need that needs to be fulfilled. Let me define that need in terms that they may not have in a way that's useful, and then go through and define how I'm going to approach the problem, what I will and won't consider, things like that. So it's kind of the start of the design process and defines the bounds with which you will operate. Then we get to the external considerations. These are anything that can affect your design or your design can affect. So a good word for that would be interact. Anything that your design will interact with or will interact with your design, anything like that. And then we get to the project requirements. In my experience making engineering design documents, these are the bulk of what you're going to be focusing on. These are the meat of an engineering design process, so to speak, where it's all the things you will consider for making a design. So I know that's a lot. I know it's a lot of theory crammed into a small area. We're going to take it step by step and go through the terms individually. So the problem statement, first bucket, the need. What is the need of a project? It is what it must do, right? So it's how do we achieve what the client needs? I suppose in your case, it's more a question that was posed to you guys and you're designing around it. But in the professional engineering workspace where I've been working for the past month, it is where clients will come to you and say, I need this, I want to do this. And your job is to define what the need is. So if we go back, I'm going to also have a slide where I ask you guys for your input in regards to this after. But if we're talking about the car example, again, what is the need of a car? Well, I would say it's to transport people. It's to transport people and things. Now, how you go about that is different. We'll talk about what the way you achieve the need is later. That comes in the project requirements. But the need is just what you have to do, what the end result needs to be for the design to be considered successful. Like if someone asks you for a car and you present them like a computer, at a base level, that already fails. It seems obvious, and it is, but it already fails the need requirement of transporting people and things. So it's not a valid design. But there could be other types of cars, like you can make a wagon with 4 wheels that has no form of locomotion and push it down a hill. Technically, that transports people and things. So that would qualify under the need section. You get more and more specific as you go through, and you rule out more invalid designs as you go. But the need is at a base level, what the design must achieve. Moving on to the scope. This one I find oftentimes gets misunderstood. Think of it like a telescope, right? You're looking through a telescope at something very far away. What does that do? It zooms in on a very small area, and it lets you focus intensely on that area. This is what the scope does. You define what your scope will be, and that allows you to hone in on really delving into the details of that area. The same way that you zoom in with a telescope, your engineering scope allows you to zoom in on the area of interest. So for the car example, again, going back to that, what could we scope to? Well, we want to make it so we don't have to consider too much. We want to focus in on a certain area. Maybe we scope it to, I don't know, land vehicles only, because if the need is just transport people, you could transport people over water to other countries. Like if I want to go to Canada or from Canada to Europe, I could transport myself there via some design. But if I'm considering air travel or water travel, the sheer number of things I have to think about multiplies exponentially. Think about those like water boats, or the water boats, the water planes, where they are planes that can also land on water. They have to be customized to have those flotation devices. You're thinking about what other things you might consider. They had to scope to both the land or the air and the water for these planes. For us, we would only scope to a land vehicle because a car is a lot easier to deal with when it's on land than anywhere else. So that's an example of scope. You're scoping into a specific part of a design so that you can define it well. And third, and probably most confusingly, the gap. This is just why you're making the design in the first place. If you, as an engineer, make a solution for a problem that doesn't exist, no one is going to use it. And the gap is kind of like a check to see whether or not you're designing for a problem that doesn't exist. Because there's an old expression: if it ain't broke, don't fix it. This is what the gap aims to avoid. People fixing things that were never broken in the first place. Why would you create a new design if something that exists works better? The gap is what doesn't work currently. So if we're talking about cars, if we go back to the car example, some of you may know about the electric car boom that's been happening recently, thanks to Elon Musk and their insistence on creating these more efficient, more environmentally friendly electric cars. But let's say you go back 20, 30 years and you're a car manufacturer and you're thinking, well, how do I go about creating a car? Well, there's all these established brands. They have their combustion engines, their cars. What if I want a car that has a lower carbon footprint and has more efficiency than existing cars, than the current solutions provide? Well, then I could design one, and the gap would be in having those cars that have a lower carbon emission, for example. So if I'm like trying to make a car better than the ones that exist, that in itself is a gap. There's a gap in better cars. There's a gap in electric vehicles, for example. So if I make an electric vehicle, that's going to be more efficient, pollute less than a combustion engine car. That's an example of a gap. It's just the gap that your design fills by existing. So I want you guys now to get some more engagement going. What do you think are some other examples of a need, a scope, or a gap for a car? I know I've gone over a few, but I've intentionally left a few out. Please put answers in the chat, see what you guys can come up with. Oh, I see here that there is some confusion about what's going on. I'm more than happy to do that. So what we're going over right now is the terms of the engineering design process. There's 8 main terms that you guys are going to need to remember, and or you can take notes on them, I'd recommend that. These 8 terms are what you categorize parts of your design into. And they come up often in engineering design. And so I'm trying to define what these terms are, like need, scope, gap. These are specific terms that have a specific meaning in engineering. The same way multiply has a specific meaning in math. And so I'm trying to give those definitions and explain things. I see one example, someone said power it on biomass. Exactly, something better than electric powered cars. That's a great example. Maybe that's not possible yet, but that doesn't mean it won't be. Maybe you could design for that. Exactly. What are some other examples if anyone wants to volunteer and answer? And again, no shame in being wrong. There's not really wrong answers with the eng design process. Hydrogen, okay. What are some other things you might have to consider with hydrogen? I don't know, we could think about that. A flying car, okay, yeah. Those are good examples of gaps currently. Yep, hydrogen, very flammable. So that might come into the other considerations when we get further down in the definitions. Maybe solar energy. All right. All good extensions of a car. So they're fulfilling the need. They have a interesting scope. Yeah. Self-driving car, all of that. All very good answers. Thanks, everyone. Now, whether or not those solutions are viable is another question because there are certain limitations. But again, those limitations change as the technology develops and as time progresses. So these are the ones I had for the problem statement, for the need, the scope, and the gap. Again, gap is a very subjective thing. It depends on the situation. It depends on what you're presented with. It depends on a myriad of factors. But overall, just remember that this is how you define a problem. You would say, what does my design, let's go back for a sec. What does my design need to achieve? The need. What am I going to consider and not consider for my design with the scope? What am I scoping into with this telescope analogy? And why can't we use an existing solution as the gap? What is the hole that my design is filling? So moving on to the second bucket, this one's a little smaller, the external considerations. Where will the design be used? This is the service environment. This one is probably the easiest to remember because it's named what it does, which you'd think more would be named like that. But the service environment is the environment that your design will service, if that makes any sense. So in the analogy of a car, could I get some guesses as to potential environments where a car might find itself? These can be physical environments. These can be, let's stick with physical for now. It's easy, but if you guys can think of more, feel free. Okay, so it's on a road. That's good. That it's going to drive on asphalt. Potential other ones may be like an all-terrain vehicle. The service environment of an all-terrain vehicle is going to be much larger and have to encompass more than a regular, just standard car. A demolition derby, I like it. Yeah, so you'd have to consider a few more things. If you're in a monster truck derby, maybe it's a monster truck car. That's going to have a lot more considerations behind it. What about the weather? Weather's a really important one. Service environment really depends on if something is inside or outside, because the weather can do a lot of damage to something. What are some examples of weather that might be useful with a car to consider, to factor in? Ice or snow, rain, hail, all of these are good. If you guys have ever been in a car with just a massive hailstorm coming down, it's dangerous. If the cars aren't designed to handle that, or you don't have the right wheels to keep traction on the road, it's very dangerous and very scary. So it's important to consider things like that. I'm sure that does a good job of illustrating why service environments are important to consider. Ice storms, exactly. Oh, you don't want to make the car too big. Yep. Yeah, size is important. We will get to that in the next section, actually. Okay, I think that's pretty good for service environment. What about stakeholders? Stakeholders are anyone who's going to interact with that design. This is what I meant earlier when I brought up the term interact, because it means they can affect the design or the design can affect them. So some good examples of stakeholders are every time you're considering stakeholders, the user and the client are stakeholders. This is an important thing to stress, because obviously the person using the design is going to interact with it, and the person who is requesting the design is going to interact with it. So in your case, you don't have an explicit client, excuse me, but the judges that you're going to be presenting to in a way are stakeholders. So you can describe anyone that interacts with the design as a stakeholder, although in some cases, and this is where it can become confusing, certain people aren't stakeholders because they don't hold enough of a stake in a particular design. So if we pivot from the car analogy and talk about, let's say, some city construction company is coming up with plans for creating a road. What are they going to have to consider in terms of stakeholders? Well, sure, there's going to be the people who use the road, the ones driving on it, but they're not really going to be considered as stakeholders. The people that would be considered as stakeholders is the community that the road is being built through, because maybe the creation, what they're building the road on, exactly. If you're paving over a community, paving through a city, that's going to not only take a lot of time and disrupt the lives of those around it, there could be adverse health effects. Like maybe it's a really loud construction process. I'm sure many of you have been around construction before. It's not exactly quiet. So there's all kinds of things to consider with the stakeholders in a regard like that. And you would want to talk to them about what they're comfortable with, what, like if they're okay with the road being built. I know in Toronto, where I am, there have been a number of pushes to build highways near where I live that the community has completely rejected because they don't want a highway being constructed in their community because the construction process would severely disrupt it. And also they don't want to have to deal with the cars driving through it. So there's all these kinds of things to consider when you're going through with stakeholders. Based on all that, what are some other stakeholders you guys would associate with cars, for example? Please drop your question or your answers in the chat. Pedestrians is interesting. That's an interesting one you bring up. You could consider them a stakeholder, but they're not specific entities. They're just part, this is where it gets weird, they could be considered part of the service environment because people are in the environment where it's operating, but it's not specific people. Whereas if you're laying a road down through a community, those are specific people who live in that community who are affected. It can be a little confusing, but you could make the case that pedestrians are stakeholders. It's just as fine. I would say there's not a ton of stakeholders with cars. I mean, you could really extend it to like manufacturers, maybe if your car requires really strange parts and you're like outsourcing it to a manufacturer, they might be a stakeholder in the process of creating it. Maintenance, yep. So like mechanics, things like that, repair shops might, if your design is really strange, it's unorthodox, they don't have manuals for how to repair it, or it uses new technologies, it might be important to consider how you will impact them and maybe include instructions or manuals or that kind of thing. There's a variety of options. Good answers. Okay. So these are the ones I had. Let me know if there's any confusion with any of these. Just going to give a bit of a breather because I know this has been pretty intense on the theory and I don't want to burn everybody out too fast. Oh, we've got an interesting point here. Yes, that would be a combination of stakeholders and service environment. That would, you could put it under either and it would be valid. I would say stakeholders. That's a very good point. If there was a school, for example, beside the road and the kids who are constantly moving across it, I would say that is a consideration. Yeah, absolutely. I can re-explain scope. Yeah, sure. So going back for a moment just to scope, please ask me if anyone is confused on this, because again, these are high level concepts and I'm trying to just give you guys a brief introduction to them in a very short time frame. I'm more than happy to re-explain. Scope is the idea of what part of a design are you looking at? What are you scoping into focus on? Let me think of an example aside from a car. So in a project I worked on in the past, we were dealing with something on the Toronto Island, and we were dealing with how to allow a fire truck to get to a region that was blocked by flooding. We scoped our design to being methods of blocking the flooding in the first place, as opposed to methods of removing the flooding once it has happened. So instead of using reactive measures, we used like proactive measures, like putting a wall in place that stopped the road from flooding, as opposed to getting some like pumps to pump the water out of the flooded road. So it's what part of the design you're scoping to. It could be a variety of things. I hope that helps clear it up. Okay, so project requirements. This is the last bucket. I'm going to go through all of this, and then there will be an example again for you guys to practice with. These are probably the easiest to remember, but the hardest to actually do, if that makes sense. The functions are what your design needs to do. The objectives are what your design should do, and the constraints are what your design must or must not do. It's an easy way to remember it. The functions is getting back to what people brought up at the start. You know, when people were saying like, it needs to be able to brake, like that's a really important part of a car. You're right. And that's a function. It's what the design needs to do to achieve the need. It's weird wording, but any functions, base level functions to achieve the need are the functions, if that makes sense. So for example, braking is a great one. The ability to start, like if it's a car, you don't want to have a hill that you can push it down to start. You want to have the ability to just start. So you need like an engine of some kind. You need a method of acceleration. What other examples? What do you guys think for functions of a car? These are like base level things that allow you to do the need. So let's take, in this case, the need as transporting people and things. What are some functions that let you do that? Lights, steering, huge, exactly. Those are really important. The user driving it needs to be able to see. They might be at nighttime. Steering, you need to be able to direct where you're going. Transport is no use if you can't transport where you want. Accelerate, heat and AC, windows. A lot of these are really good examples, guys. Vision during a storm. We'll get to constraints in a second. I don't know if, well, there would be a, yeah, sorry, I'm just thinking. We'll talk about constraints in a second. Don't go there just yet, because there's a very specific meaning. You're half right on that one. Windows automatically clear themselves, heat, all great answers. So these are functions that allow the design to operate. That's perfect. So let's go back to, oops. So back to this, objectives. Anything the design should do. Now, these are where you have a lot of creative freedom. These are where you decide, like, what's the difference between a minivan and like just a regular car, like 4 seats, that kind of thing, versus like a big 6 or 8 seat car or a limo even. Objectives are what the design should do. So maybe there's a type of car that you could build that's really lightweight, like it has low cost. Cost is generally an objective. If something is low weight, it should be as low weight as possible, but maybe you have compromises that make it higher weight than it otherwise needs to be. Or maybe with size, if you want more people in your car, it should fit as many people as possible, right? But there are other things that you have to factor in with that, because it should also be as low cost as possible. And the bigger you make it, the higher cost it gets. So objectives are ways in which you would evaluate your design. They're ways that you can compare two designs. So if I had one car that's smaller but costs less, and one car that's bigger but costs more, how am I going to evaluate them? You would use objectives. What do you guys think are some other objectives for cars? These are like things that you would want them to be, but they don't necessarily need to be, like with functions, where like you need to be able to steer a car, but you don't necessarily need to be able to fit 20 people in a car. More room. Yep, the car will change size with work. Speed, yeah, you could have higher top speed, like a sports car is definitely going to beat a minivan, for example. A sunroof, yeah, if you want to have that as a thing. Generally, objectives are like, yeah, I guess it would depend. Yeah, it would depend on a few things. So sunroof is valid. Rolling down windows. I think seating is probably more of a function, because you need to be able to comfortably contain the people. But you could argue that it's an objective too. Yeah, I'll give that. Low emissions, that's a huge objective. That's really, really big nowadays. If you have a low emission car, you're much more likely to be produced. So for anyone confused on functions and objectives and their differences, oops. Functions are the needs, like it will not function as a car without these, whereas objectives are things that you should have as good as possible, but they don't necessarily need to be. So the ability to drive the car, like to steer it, is a function, whereas the ability to drive at 200 miles per hour is an objective. You don't need that. It's kind of like a want versus a need, where the need is the function and the want is the objective. It's just what the design must do versus what the design should do. Yeah, fun colors is a good example of an objective. You could have fun colors, but it's not required to drive a car. Okay, perfect. So then we'll go on to constraints, because I see you guys keep mentioning constraints. Generally speaking, constraints are a legal thing. So a constraint of a car is that it needs to be able to drive in a car lane. So, you know, trucks can be really high, but you never see a really wide truck. Like, what if you made a car that was like 2 lanes wide? Not only is that not going to work because of, you know, you need to be able to steer it, but it violates the law. And so the constraints are things that you need to abide by with legal consequences. So if you put anything in a constraint, there is legal consequences for violating it. Not for you guys, but in the professional engineering space that we're kind of imagining we're in, violating a constraint is a big no-no. So constraints are just legal aspects of a car that you cannot violate, or they could be physical requirements. For example, if you're building something in a room, like let's say I need a table and I'm designing a table for my house. If I can't fit it through the door, it's not a good table. So the constraint is the physical requirements for a design, or the legal requirements for a design, things that you cannot violate or else the design is rejected. What do you guys think would be some examples? I see some messages in chat. I don't know, I see a question by Audrey. I don't know if there are a ton of constraints in this project, mostly because you guys are not dealing with a professional sense, but I wanted to give the overall view of what the functions, objectives, and constraints, or as they're sometimes called FOCs, are, so that you have a full grasp of them. Constraints, you don't want a lot of them. They're just things that you absolutely cannot do for your design. Seat belts, absolutely a constraint. You have to have those to keep up with requirements and laws and standards. Absolutely. Do not want. Just looking through. Yeah, if the design must, for example, follow the relevant road standards. So if your emissions are too high, like was mentioned earlier, an objective can be having lower emissions than the standard, but a constraint is being below the standard at all. You can't exceed the standard. Like if you're not allowed to put a car on the road with X level emissions, you can't violate that constraint. That's a good example of what a constraint is. And in regards to this competition, like was mentioned, you're probably not going to have a lot. License plate holder, exactly. Okay, so those are the project requirements. These were my examples of functions, objectives, and constraints. You guys managed to get quite a few of them. And then after this, we're going to go into a quick summary, do an example for you guys to really apply what you've learned here, and then we're going to go and enter the Q&A session. So I hope all these make sense. Yeah. So this is the summary. You have your need, your scope, your gap. These are the problem statement terms. These are the ones that define what you're going to be looking at in your design. Then you have the service environment and the stakeholders, which are the external considerations that define what the design is going to interact with and the things you may need to consider around that. And then finally, you have the project requirements, the functions, objectives, constraints. I'm going to go through each of these one by one, just so you guys get a defined term for each of them. The need is what your design must achieve to be a valid design. Your scope is what types of designs you will consider and what types you will not. The gap is what is the hole that your design is filling. Why does your design need to exist? The service environment is what environment, physical, or it can also be virtual, I neglected to mention, but it's just any environment that the design will operate in and the associated conditions of that environment. The stakeholders are who is going to interact in a meaningful way with the design. And then the FOCs, the functions, objectives, constraints. Functions are what the design needs to do to achieve the need. It's what the design must do to achieve the need of transporting people and objects. Objectives are what the design should do. So can it drive 200 miles per hour? Can it fit 8 people? Does it have a sunroof? Anything like that. And then constraints are anything that you must do. Does it fit in a parking space? Does it fit in a in like clearance height? Does it fit in a proper roadway? Does it follow safety laws, emissions, things like that? So those are the 8 terms of the engineering design process. There's more, but this is all you guys will need to know for your work here. So we're going to go and let you guys have the opportunity to think about everything you've just learned. We did the example with the car and you guys gave some great suggestions, but now you know the words that you can use to describe what you're talking about. I want you to come up with examples for each of the 8 terms. Doesn't have to be many, but just so you guys get an understanding for if you were tasked with designing a vending machine, what things are you going to have to consider? If you need to make any assumptions about what the client's asking, do that. Whatever you want to design this for, all I'm asking is for a vending machine. So take a few minutes, think about that, write down some examples, and then we're going to do some sharing in the chat in a minute. And just talk about them, have a quick discussion. And then with whatever time is left over, we'll do the Q&A. And for these minutes, you don't need to type anything in chat, just take some time and think to yourself. If anyone wants a refresher on terms, I'm more than happy to do that. Okay, so I'm being suggested maybe walk you guys through it. Okay, that's a great idea. So vending machine is the topic of interest. How would you design a vending machine? Let's go through and talk about each of these. So what is the need of a vending machine? What would you guys want to focus on? What does a vending machine need to do to be a valid vending machine? What are the core actions it must take? Give out snacks in exchange for money. Perfect. Contain and dispense drinks, etc. Yep, perfect. Be able to restock snacks, also a very important point. You need to be able to put more in over time and to make sure that the buttons work. All good examples. But the core ones, I would say, I don't actually have examples written down. I wanted this to be a discussion. I would say the big ones are to contain and dispense, contain snacks and dispense them in exchange for currency and to be able to be restocked. But all the other ones are equally valid. Make sure electronics work, things like that. What about a scope? What is the scope of a vending machine? What could be a potential scope? There's not one, there's many. Type of food, that's a big one. So is it a chip vending machine? Is it like sweets? Like I'm sure you guys have seen how sometimes there are vending machines that are just all like different types of drinks like water, Powerade, Gatorade, things like that. Scope is, to answer your question, Kristen, scope is the type of design you will consider. So I would say the major one for vending machines is type of food you are selling. Exactly, healthy food is an equally valid scope. If you want to have bags of kale chips and guacamole, yeah, you could sell health food. There's a number of different scopes, but they all kind of revolve around the type of food sold. So I would say we've already nailed scope. Gap, there's a lot of potential gaps. Just throw out some ideas that you could have if you were making a type of vending machine with the goal of being needed despite the presence of other vending machines. This one's hard. People need fast and easy access to foods. Yep, that's a great gap. Like maybe in the workplace that you're in, there's not enough access to food. People need a quick way to get it. A vending machine is a perfect solution to that. So that's a gap, exactly. Let's see, it would need to be kept cold. I would put that under a need, for example. Yeah, that would be a need to accompany the scope. Yeah. Okay. Good suggestions, everyone. Dimensions. Okay. That might be closer to one of the FOCs. Has to be close to an area full of people. Yes, that could be an objective, but that could also be part of the need or the scope. Actually, wait, what am I saying? No, that's the service environment. Let's actually move into the service environment and stakeholders. We'll start with service environment. What are some examples of that for service environment? Where would a vending machine be located? What things might you have to consider? Food court, office, snack bar, power outlet. Nice idea on the power outlet. That might actually be yeah, that's good. The sun. Yeah, so that's, wow, some really creative answers. I really like this, guys. Service environment examples in a school, for example. Perfect. Solar panels, anything like that. We don't have a ton of time left. Q&A might be cut a bit short. We're just gonna go through quickly. What are some stakeholders? And then if anybody has functions, objectives, or constraints, please throw them in. I will take a look and categorize them so that you guys know what I would call them as. This is the quick fire round. Yep, people using the vending machine, absolutely. People who of all ages who would buy the food, absolutely. All good stakeholders. What about some FOCs? What about functions, constraints, objectives, anything like that? Yes. Okay, that's a good function so that it can't be stolen from, so that it has to have money traded for goods. It can't be money taken for free. A good constraint is be able to fit indoors. It needs to have the physical dimensions to fit indoors. Dispense food, that's a core function, perfect. People maintaining the vending machines, yep, that is a function as well. Okay, any more last answers coming in with this example, and then we can get to the Q&A session. Yep, be restocked as a function, accepts money. Nice. You'll see that need and function have some overlap. The need is like a result-oriented thing, whereas a function is a how do you get to the result-oriented thing. So if the need is dispense money and not dispense money, dispense food and accept money, the functions may be have a device that can actually accept money and then dispense food in exchange, like the spring systems. Make sure vending machines can't be hacked. Perfect. Okay, so I think we're going to call it there for the vending machine example. Excellent examples, guys. Let's move on to the Q&A. Do you guys have any questions for me about engineering design, about my experience as an engineer, about these terms in general, anything relating to the topics covered here?
Thank you, Ben. I just want to make a quick announcement. Blake, I don't know if you're here, but we have someone on our team who just wants to make a quick announcement before we start answering any questions.
Right, so again, if any of you guys have any questions throughout the competition, you can feel free to email our help email. I'll post in the chat over here. And we're also going to be, we're thinking of hosting another workshop meeting for engineering, just to help you guys sort of relate what you learned today with your actual projects for SRHacks. We're thinking of running that on Discord. So again, you can also join our Discord if you have any questions about the competition. Now, to join Discord, you would have to use your parent's account to join, and your parent also have to participate with you in any Discord activities, because Discord is for people for ages 13 and up, right? So I just want to make a quick announcement about that. So you can ask questions during the Q&A, and we will also be holding another workshop via Discord to sort of help you guys relate this material to the your actual projects for the competition. Yeah, I think that's about it. So
Awesome. Thank you, Blake. I saw a few questions in the Q&A section asking about if this will be able to be viewed again. I believe this is being recorded. If it's not, someone can double check me on that, but I believe this will be recorded and posted somewhere for you all to look at. In terms of applying this to the design, because that was another question I saw, these are just ways to categorize the types of things that might be in your design. Not all of them may be present, like there may be some you don't have, like I don't expect there'll be many constraints, but this is just a way to be like, we have a design, how do we take this and put it into an understandable format to communicate to the judges, to communicate in our presentation, that kind of thing. It's meant both for you guys to learn and understand, because it's useful and I think interesting to know about this stuff, but in terms of the project, it's more of understanding how engineering design is done and ways in which you can take what you have with your design and convert that into an engineering form for display in your presentations. Let's see what else. I don't know if there's any other questions. I'll be sticking around for a tiny bit more if people have questions. Thanks everybody for attending. I hope this was informative and fun. I know learning a lot of theory can sometimes be a bit dull. I hope I made it as engaging as I could. And if anybody has questions about engineering personally, you can email me at my email on screen about engineering or engineering design, anything relating to that. Not so much in respect to the workshop, because I think it would be better if you just look at this recording again if you have questions about what the terms actually mean or are. But if you have greater questions outside of that, like what engineering life is like or anything of that sort, send me an email and I would be happy to discuss. Thank you guys for being a great audience and interacting as much as you have.
So we actually do have a question from Mohammed. He's asking, what does a chemical engineer do?
A chemical engineer of all engineering types can do a lot of things, probably the widest range. Some are like in pharmaceuticals. Some are in, like what I'm working in currently is like process design. So, you know, when there's big like power plants or like, I don't know if anyone here knows the show How It's Made, where they have those factories where products are created. Chemical engineers focus on the creation of those the creation of products, the creating of processes, and sometimes we work in a lab. Like Mimi and I would have had lab experience this year if not for the pandemic, but generally speaking, chemical engineers have a wide variety of skills dealing with both chemicals, but also processes. So it would be valid to call us process engineers as well as chemical engineers. All right, it looks like we're coming up on end of this presentation. I hope everyone enjoyed it and learned something. Best of luck in SRHacks.
Alrighty, thank you for your presentation. So now we just need to wrap this up.
Sure.
Thank you so much, Ben. This was a great presentation.
Let me stop sharing.
And is it Sophia who's running this? Can we start having this, get some elevator music or something?
Okay.